Okay, so we'll try these out and we'll get a quick lesson on things falling, since that's one of our easiest and best things to study in honors physics. Uh, let's see. So one car is traveling 30 meters per second east. When the driver hits the brakes provide constant acceleration of 6 meters per second west. Find the time and distance required to stop the car. Okay, these are our, yeah, you should. This is like smushed into my giant notes page, and I've clipped it here for you. So, but anyway, you have access to this text. So I would just try to pull out the important information for you. Okay, on test questions, yeah, I would print you a question, but I would definitely write down the key information. Okay, and so in physics, this would look pretty much like this. We have to have a reference frame. So I would have east equal to like plus x, and then my west is negative x. So we're getting our one-dimensional motion down. Okay, so I would actually call this v0 is plus 30 meters per second. I'll try to leave myself more space there. Okay, a constant acceleration, 6 meters per second, right? The rate of change, or meters per second squared, the rate of change in velocity. Now, if that one's east, how should I write west? It should be negative 6. Okay. Now, there's some strategy to this. What if I say, okay, find the time and distance required to stop the car if I go, okay, I'm going to use delta x instead of x minus x0. Let's not even, while I'm debating that, I can just say, because they didn't give me any information, let x0 equal 0. I can choose the coordinate frame. Physics has got to work in all frames. The same physics has to work for us here in the room, and the us that's whipping around the Earth's axis, and the us that's whipping around the sun. It's the same us. It better all work, even if I change reference frames. So let's make a simple choice and say, okay, x0 equals 0. So I could start plugging away. X equals v times t plus 1 half at squared. Hey, oh, there's some problems with that. Do you see why I shouldn't start with that one? It's the one at the top. I might go down the list. What do you think? Okay, so it's also asking for the time. Time is quadratic in this equation. Remember the quadratic equation? Oh, good for you. You should probably forget it. You don't really want that. There's a better trick. Welcome to physics class. I don't know that either. Maybe that should be a different color. I don't know the distance yet either. So be careful which step you start on. Okay, I don't know any of this. And so they're not magic formulas. Okay, I'm going to need to figure something out. Fortunately, there's a given piece of information that I missed. What's that? Sure. Oh, sure. What would you like to say? I definitely need another equation. And there's an important clue. Go ahead. That's right. Not all your clues are in numbers. The car comes to a stop. So I have a final velocity. I'm too lazy to write f's, but you can write vf if you want v sub f. The final velocity is 0. 0 doesn't need a direction. It's the best number. Okay. Oh. So I actually could use equation 1. Exactly. And since this is honors physics, you can just write. That's why I'm numbering them carefully and confusing myself. Number 1, the time equals, And I already labeled the v's. I don't even need that. Okay, the time equals 0 minus 30 divided by negative 6, 5 seconds. If you have space, you can just write 5. You can write off to there. That's the steps that I need. Because look, we already wrote this is V0, this is A. With the units, I wrote down the units. Saved us all about the time. Okay. There usually won't be tests where I need to see your work with units and on the formulas and stuff. But once every 9 weeks, actually, we will do one. It's a pain for me to grade, but sometimes we have to do that. In AP Physics, every test has at least one problem where you have to show all your work and you have to show one time. There's the given problems, there's the formulas I used, and that stuff. So when you're doing homework and they already gave you everything, you can just write the one step in the answer. That's what I mean by details. But if it's not obvious, it's really going to help you to write things out and notate them. Okay, and then once I have 5 seconds, then I do know the distance. If I plug in 5, it's 5 squared times 6 times a half, that's 45. V0, 30 times 5 is 150, 195 meters to stop. That's a lot of meters. I hope we weren't in a hurry to stop. Is that a reasonable answer? I think so. Okay. Anyone disagree with that answer? I already wrote down what to do. So yeah, this is like a show your work class. Oh, sure. You're right. So x0, yes, just disappeared because I started that at 0. Maybe I should think harder before plugging things in, though. That's not right. Why isn't it right? Oh no, don't just nod along. This is how I have to play with you. Okay, it's plus 30 times 5 is 150. Oh no, directions. But it's minus 6, so let's do minus 3 times 25 is only 75. Oh, still pretty slow stopping, but much better. Now you all agree with me? It's 1/2 times negative 6 times 5 squared. So negative. We're going east to begin with, and we accelerate west. So it makes sense that those terms work against each other. Okay? Right, then the formulas, you're math geniuses. So these formulas are really easy. But I gotta understand that has to be negative. I have to understand, like, you can't forget the negative sign, and all I did was give east and west in the directions. It never mentions negative anything. You just have to understand. Put yourself in this situation. Okay? It's not going faster and faster. It's going less. Okay. Half the time. Fantastic. Any other questions about this one? Okay, we'll do a short interlude for silliness. We'll say minus 9.8 meters per second squared, or I think it's 32.0 feet per second squared. They're all negative because gravity, of course, points downward, and we probably want up as positive. Next chapter, chapter 3, if you get sick of gravity being negative all the time, what would you say, Calvin? Is gravity negative always a good idea? No. Calvin liked to take the shortcut of flipping the axis. We could build our world upside down if we wanted to. So there's not negative signs everywhere. But what are we going to do? Because it's actually 9.81 or 9.82 or 9.806 or something like that, I usually just say g is 10 meters per second squared. Some physicists would say that's blasphemy. You have to remember down, of course. But there's only a 2% difference between 9.8 and 10. Yes, sir. Please use 10. When people ask, it's fun, isn't it, Calvin? When people ask, I will give the answers both. But you'll only usually, if all you did is multiply and divide, you'll only be off by 2%. And on a test, I will never split the answers apart by 2%. The right answer will be at least 10% away from any wrong answers. Usually more like 50% or a factor of 10. Okay? So you never have to get it closer than 2%. Okay? When it's time to bore you with experiments, I'll I'll talk about why what that actually means that you have that last significant figure. But it means it doesn't matter very much. Okay. Okay. And it should be, so it should be intuitive that things just fall faster and faster. Okay, we'll do experiments that measure the G, and I bet, I challenged the AP classes last year. Using all our equipment, even the high-tech equipment, could they actually measure G to any closer, could they prove that it was 9.8 and not 10? And I think only one group succeeded, and they said, our experiment's not that great, just use 10. Okay, but so I can release an object from rest. I've got like an ink pen in my hand here. I can release it from rest, and it's not moving. And then it starts to move down, and then it moves down faster and faster and faster. So at least we can agree that things, when released from rest near Earth, start to fall, and they fall faster and faster. So they're accelerating down. Okay? Yeah? No one doubts that? Because, that's not the only way you could have a certain result to that equation. No? Okay. That's a whole other chapter later. Anyway. Okay. So if you hit a baseball straight up with 49.0, I meant to use 9.8 here. Just to mess with myself. Okay. Right? Now, let's fix it. On a test, I would say 50 meters per second and not 49. Oh, an initial position 1 meter above home plate. How high will the ball go, and how long will it be before it returns to its original position? Ooh. Since we're talking up and down, let's use y instead of x. Okay. Well, and let's write down what we've got. Okay. We've got our v0 is up at 50 meters per second. We've got our acceleration, is minus 10. We've got our y0 is 1 plus 1 meter. But we want how high will it go? Maybe above the ground. Okay, sure. When it returns to its original position. I could. I could. And on a test question, yes, for this, as this question is written, how long till it returns to home plate? And then how high will it go above its original position? Oh no. How high should imply above the ground. So if you can, if you set this to 0, you just remember to add 1 at the end. No, you'll forget? Good that you know yourself that well. I don't think I'd forget, but I might. There's a chance. Uh, are we missing anything else? How long before it returns to its original position? What's your vertical displacement? How high will it go? Okay, so I'm actually trying to solve for y. In that first question, how high does it go? Oh, wait. Oh, I don't have the time. I don't have the time for it. Like, I could start writing y equals y0 plus v0t plus 1 half at squared, but I don't know t again. It's just like the other problem. But how did we get t in that other problem? All right. If I throw something straight up, how do I know when it's at the top? It's actually stopped for an instant, and then it's going to accelerate. It's going to start to come back down. Oh, don't worry. It's a couple weeks before you have to do that on the test. Yeah, to answer how high, this is the place where v final equals 0. So I could get the time by just doing final minus initial, 0 minus 50, divided by the acceleration. Oh no, it's like I'm messing with you. It's 5 seconds again. But that's not one of the answers. That's how long it takes to get to the top. Okay? So I'll make sure to remember the negative sign this time. Okay, y is 5 times 50, so 250 meters up, minus 1 half a t squared, so minus 125 meters. Okay, so we'll call this y top. Y at the top of the flight is plus 125 meters. Oh, and that's its displacement. So let's write 126. Delta y. The same deal. How long? How long till it returns to its original position? There's a shortcut for that one too. Don't tell him, Calvin. Right? You look at these equations and you think you know them, but it's going to take practice. My AP students have all forgotten over the summer, so don't feel bad. They should know. There's no air resistance, there's no interference. It doesn't hit anything on the way down. So with the same acceleration, that's a deep thought. I think it's going to take most people some time to get that. But it's going to be like a symmetric parabolic trajectory. Okay? Every second you go up, think of it, every second you lose 10 meters per second. So I'm going to slow down from 50, 40, 30, 20, 10. And then every second back down, it's going to add back 10 more, heading down, 10, 20, 30, 40. It's a perfectly symmetric thing. So if it took 5 seconds to get to the top and stop, it takes exactly 5 more to get back down. And when it falls down, this is not realistic because we neglected air resistance. But when it gets back down the other side, it's going exactly as fast as it did when it was shot straight up. Okay? If that's a bit of a leap for you, I totally understand. Most people don't get that on the first day. When it returns, it hasn't moved at all. Okay? So you can actually use that same equation. Delta y equals v0t plus 1 half at squared. And you say 0 equals 50 times t minus 5 t squared minus 1 half acceleration times the time squared. And that's an easy, it's not even a quadratic because the t's cancel out. But that's a really easy quadratic to solve. Okay? It has two answers. But we already knew one. One answer is 0 at the start of the problem. It was right where it started. That's what it tells us. And the other answer that fits that problem is 10. Okay. Any questions? Sure. That's 1/2 AT squared. So half of 10 is 5. Good. Yeah, no. I've got this big clunky whiteboard. This is really a giant tablet hooked to the wall, like you might have an iPad or a kid's tablet at home. And it's hard for me to write really fine and detailed. I don't have as much space as I would like on a whiteboard, so I'm leaving steps out. You're also all qualified math geniuses, so if and it's fine if you first learning this. That's really natural. Do I have enough time? You've got only got 15 minutes till lunch. I think maybe we better just chill and you watch the video next time. The video's fun, but it's kind of annoying. So if you're lost on my steps, this is an important learning experience for you. Go back to the equations as listed. We'll be talking about equations 1, 2, and tomorrow introduce number 3. Go back to the equation, or you could ask me to do another page. That's fine. Go back and plug things in one by one. I make mistakes plugging things in, like you saw on the first slide. Okay, so that's normal for that to happen. Okay, especially at first. But good. That's where it comes from. So time is 5 seconds squared times 1/2 of -10. It's -125. Good question. Any others? Okay, I've talked enough. Made 2 videos.